Yeah, cool. Okay, hello everyone. Yeah, I'm really excited to be here. And in this session, I'm going to show you how we can use Apple's native tech stack to create various spatial games for visionOS. So the topic of today's session is drop the beat. It's not just about starting this interesting journey, but also indicating that we are going to build a beat game and show you how we can build that with a native tech stack. So now let's jump right in and explore this interesting project. So firstly, let me introduce myself. My name is Xu Chi. I'm from China, and I worked for ByteDance, Morgan Stanley, but now I'm an XR developer, mainly focusing on Apple Vision Pro. So I know that my name is a little bit to pronounce for Korean speakers or English speakers. So on Twitter, I call myself Chester. So if you are interested, just reach me out and let me know anything we can chat or discuss anything. Okay, so before the release of Apple Vision Pro, I believe many of you have already used some other XR devices like the Quest, like Pico. These platforms have plenty of well-established and entertaining games. And with the release of Vision Pro, we've also started seeing more and more games, exciting games coming out. So now let's take a look at some differences between these games across these platforms. So first, let's go over some popular games on Quest. So in Quest Store, I'm sure you are familiar with the titles like Gorilla Tag, VR Chat, and Roblox. They are all social multiplayer games, and there are also some like FPS games like Pavlov and a very globally famous music game Beat Saber. Each of these games offers unique features, and all of them provide immersive experience in different ways. But on the other hand, let's take a look at some games and experiences available on Apple Vision Pro. So we can see multiple player board games like Game Room, and it uses spatial persona and let people to play in the same virtual space. And we can also see various interesting puzzling games like Black Box and Luna. So even though the game ecosystem on Apple Vision Pro is still in its early stage, and these games are generally smaller in scale compared to those in Quest stores, but we can already spot some interesting characteristics and trends from these typical games. So to summarize, I think we have three key points. So games on devices like Quest, they typically have fully immersive environments. For example, if you are playing Gorilla Tag, then you are in a space with trees and wood houses, and we need to interact with the characters, use the controllers, like use two controllers to move ourselves. And all of them are highly virtualized avatars. Like in Gorilla Tag, we are gorillas. And in contrast, the experience on Apple Vision Pro is quite different. So with the built-in pass-through, many games and applications are more focused on mixed reality. If we go back, we can see all these 6 games, we can not only play the games, but also we can still see our environments around us. The second is about the control. We know that Apple Vision Pro don't have controllers, so we have to use different ways to interact with the games. So mainly it's about eye tracking and hand gestures. Sometimes it's only about hand gestures. And the third one is about the avatars. As mentioned in Quest, we have fully virtualized avatars like gorillas, like some avatars you just customize for yourself. But in Apple Vision Pro, we use our own spatial persona. So many developers also opt to the spatial persona feature instead of creating their own virtual avatars. So we also explore some of the different types of games, and we actually building on those 3 key characteristics I just mentioned. and pushing the boundaries with innovation. So here are a few games we have already made. Some are games, some are available on the Apple Store, and some are still prototypes. And the first one is the fruit merge game, aka the watermelon game. I believe a lot of you have played this watermelon game in your iPhone. It's just match two different kind of fruits together and it will pop out. So we took this classic 2D merge game and expanded into 3D. Watching the fruits merge and disappear right in front of you instead of in your little tiny phone screen is much, much more satisfying. The second one is Special Gomoku. So it's a 5-in-a-row game, but this game leverages Apple's spatial persona feature. So it allows us to play with our friends in virtual space, just like game rooms, and we can play the Gomoku game face to face. And we can chat and play, making it like we are in the same room. And we even thinking about add a new feature called flip the table. So if I'm going to lose, I will just flip it. And that will make it more fun and more interactive. And the last one is GG Beat. This is a rhythm game, and it challenges both your mind and your body. So it's fun and doubles with a workout, providing the games that proving that we could play the game at the same time we can work out and keep fit. So these first two games, they are all mixed reality games. And the Special Gomoku game uses spatial persona feature. And all of these use hand gestures and eye tracking. So it fits all the three key points I just mentioned: more mixed reality, more hand control, and more realistic avatars. Next, I'd like to share how we went about building these games. So when it comes to developing apps for visionOS, there are generally two main aspects or two main different approaches. The first one is using Apple's native tech stack. On the left side, it includes, of course, Swift and Reality Kit, AR Kit, Reality Composer Pro. This is all set in the same ecosystem. And the second is about using third-party engines like Unity, UE, and Godot. Many developers may think that if we are building some standard apps like to-do app, to-do list, calendar apps, just like in our mobile phone, then we can use native tech stack. But when it comes to games, we should use the third-party game engine. But however, the games and prototypes I just mentioned about, they are all built with Apple's native tech stack. This approach not only allows us to fully harness the hardware capability of Apple Vision Pro, but also make it easier for developers who are already very familiar with Apple's tech stack like Swift. And these kind of developers can jump right into game development and create their own funny games. And yes, so today we will mainly focusing about the native tech stack. And then I will, then people will say, okay, if you use native tech stack, of course you can build very simple games. Like I mentioned, Gomoku game, very easy games. But how about some very like massive games? We all know Beat Saber, of course. That kind of immersive, that kind of interaction, can you achieve that only use Apple's native tech stack? The answer is yes. And we can handle that kind of bigger projects. So today I'm going to introduce how we build this GG Beat game purely in native stack, and it's even less than 500 lines of code. Then we can build a prototype of this kind of game. But before we dive into the code, dive into the details, I want to highlight that something important. We did not only rely on Apple's powerful tool stack. We also use a lot of AI tools to help us. And thanks to AI, we are able to make the rhythm game and the gameplay experience smoother and more seamlessly. and also customize some of the experience. You could say AI is a hidden hand or the hidden friend behind the scene, making everything easier. Then we can jump into how we can step by step build this music game. I'm sure all of you have noticed that the image I just showed about our game, we have a very beautiful, cool skybox, which is a cyberpunk style skybox. So how to make it? And thanks to the new feature in visionOS 2.0, we didn't even need to write a single line of code to create a new skybox. So using Reality Composer Pro, we need to only hit the plus button on the left and select environment, adding a sky sphere. And instantly, we generated a default sky sphere. But now the next question is, how can we create the texture that is applied to this sky sphere? So in the past, we have to manually create that sky sphere texture or take some photos to make it, or find some existing resources and apply it to the sky sphere. But if we want to generate unique environment for different songs, for different genre of songs, what should we do? These old methods are not work anymore. And we find out there's very helpful tools. This one on the left is a Skybox AI. So this tool will help us building very, very beautiful Skybox textures. We just need to enter a few prompts, and it will generate these textures in just seconds. We can generate just like the Skybox. We have cyberpunk style. We can also generate any other style you need, realistic or even a Van Gogh painting stuff. We can do that just in seconds. And once we have this generated texture, we can import it into Reality Composer Pro and apply it to the sky sphere we just added. So building this environment becomes very, very, very simple. And now you can see that on the right, we've already have a very beautiful cyberpunk skybox. So next, let's talk about the music. Of course, you can use your favorite music track, but if you want to avoid copyright issues or create your own music, we can still try AI tools like Suno on the left. These tools can help us to generate original music track in various styles. You can then use Apple's AV Foundation to play the songs we created. We won't go into too much here, but it's a very straightforward process. Just generate the music and play it. Then the problem is, how about notes? Because we know in music games, we have to hit or slice the notes, right? So once we have the music, the next step is adding the notes. So for the first step of this project, we use this model. We can see here on the right side on the bottom, we find a model. And we just need this line of code, entity.load API in ReactKit to load this node model. It will be put into the scene. And this node will be used as a template of more nodes in the future when we are generating different nodes for different beats. Then the next question is, how does these nodes move in sync with the music? Then we find another useful tool, which is called BeatSage. This tool allows us to upload our music. We generate it in Suno, and it will return us a JSON file with the timing, position, and even the hit direction of each node. So for us, the most important data are about the timing and position. This tool designed 12 positions here as we illustrated, and developers can put those nodes accordingly and let players to interact with nodes from different positions in a fully immersive environment. So now we have the model. We have a BeatSage to help us. The next step is we need to let the models move. This is also very familiar. I believe everyone is familiar. It's in Swift UI. We can use animation. So we can break down into two steps. The first step is we can clone the template we just loaded to our project, And then we can specify each node that you should start from here to another place and at a specific time. It's just like 5 or 6 lines of code. Then the node will just like this move from the back to the front, and the user will feel like the nodes are moving towards them. So let's see how it runs in a simulator. Yes, so with these codes, then the nodes start moving, and the next we are eager to just hit or just to slice them, right? As mentioned earlier, on platforms like Quest, we have controllers. So that's why Beat Saber has sabers. They use sabers to attach to the controllers and to slice the nodes. But in contrast, on Apple Vision Pro, we are more highly on eye tracking and hand gestures. If you don't want to test your eyes, then we prefer use pure hand track, because if you use your eye tracking to punch the nodes, then you will be very tired in just seconds. So therefore, we decide to use pure gesture. We want to make it simple and direct and providing some great way to relieve your press. So we decide to use punch. Of course, even in virtual world, we need to protect our hands. So we have to attach two boxing gloves to our hands. Then we can use ARKit's capability, which is the hand tracking capability for this purpose. As shown here, ARKit provides many features for perceiving the real world, including the detailed hand tracking. So it can identify your hand. Each hand has 27 joint points on each hand and accurately track the joints in each finger and the movement of your whole hand. So to achieve this, we first need to create an ARKit session object. The ARKit session object is at the core of obtaining ARKit data streams, managing the entire state and the life cycle of the AR environment. After creating the ARKit session, we need to inform the session that what kind of information we need. So this time, in our case, we need to track our hand, right? So ARKit, the real-time tracking data is provided with a data provider. We have tens of different types of data providers like plan detection, scene reconstruction, image tracking, object tracking, and this time we use hand tracking. So we initiate a hand tracking data provider and register it to ARKit session. Then after the registration, we just run the ARKit session. Then the ARKit session starts receiving continuous stream data of hand track, including joint information and as well as the wrist information. In our case, our requirement is simple. We don't need to track each finger. We just need to get the overall position of our hand. So we only need the information of our wrist here. Then attach the gloves to our wrist. It will just be like this. Put a glove here. We can see the result. Yes, you can see that we are successfully attaching the boxing gloves to our hands. However, if you notice that we can still see our real hands in that video. So if we want to visually hide our hands, the actual hands, in this scenario, RealityKit provides a very simple way to control the visibility of our arms. When we are declaring our immersive space, then we can easily put a modifier there to hide the upper limb visibility. Then we will hide. We can only see the gloves instead of both the gloves and our actual hands. So now we come to the most relaxing part, which is eliminating the nodes. RealityKit provides collision detection capability, and we need to set up the corresponding collision body to different objects. In our case, is set the collision body to the nodes and to the gloves. Here we define a rectangular collision body for the nodes. And when it comes to the globes, we don't have to set a very precise shape of the globe. So we set it as just a sphere. Then when the sphere collide with the rectangle, then we should do something. Then the next step is we should detect the collision of the nodes and our globes. These settings for the collision body can entirely achieved in Reality Composer Pro. We don't need to write a single line of code. But if sometimes we need to change the shape or change the position of the collision body, we can also still use the Swift code to control the collision body. And in the right on the right panel, we can see this is achievable use the collision component. So what is a component? I think it mentioned earlier in the morning sessions. It's the RealityKit's architecture. It's called ECS, Entity Component and System. So collision component use similar ways. It designs to reuse the functionality and content with a component across different entities. If you apply that component to different entities, even these entities are not in the same inheritance chain, they can share the same behavior. So we use the same technical here to make them the collision workable. So once we have the collision bodies, the next thing is to define the behavior after we detect a collision happens. Here we use the feature called collision event. And we can focus on different phases. And this event specifically listen to the beginning of the collision effect. And then we do something. And in the sample code, we can see what we are doing is just to check what kind of collision bodies is collide with each other. If one part is a node and another part is a globe, then we just remove the node from the scene, which is pretty simple. But however, if we just remove the nodes from the scene, it is not satisfying enough. So we need to add some sound effect, and as well, we need to add some visual effect. What we do is that we add some sound like pooch when it happens, and put a particle effect here. It is like firework. And then people will aware that they hit the note, and we get one more score. And let's take a look at the effect. Yeah, this is also on simulator. We just use our mouse to click the notes. We can see it again. And when user hit the note, then there will be a particle effect. So actually now we've completed the basic gameplay of the setup. And the next part is to consider the actual scenario that the players are playing in their real home. So when the users interact with this application, they are not only need to keep an eye on the game itself. They should also keep an eye on the environment they are standing, right? Avoiding accidentally, punch anybody else or punch the desk just around them. So we should use mixed reality features. As we just mentioned in the 3 key features, we should bring the mixed reality here. So do you know that there is a very powerful and fascinating feature on Apple Vision Pro, which is the portal. The portal is will open a magical window on your actual environment, and there will be another world behind the portal. So we can create a pure virtual world behind that portal, and users can see the whole world from that window. So if we are using this feature, users don't have to fully immersive in the game. They can play the game at the same time. They know that they are standing in their living room and avoid any accident. That also adds some fun to this game. But in the early stage of Vision Pro, in visionOS 1.0, the portal is more like a closed portal or closed window. People can see the different world from the portal, and but they cannot interact with them. Those entities behind the portal cannot go through the portal and appear in our real life. But in visionOS 2.0, we have a new feature. I believe everyone, if you tried Apple Vision Pro, when you are trying the Encounter Dinosaur app, you will be impressed when the dinosaur just come out of the portal and their head just popping right in front of you. This indicates that we are eager to have more interaction with the world that behind the portal. So in visionOS 2.0 system, Apple introduced these two advanced options, which is clipping and crossing. So the crossing controls whether the object in the portal can pass through from the virtual world to our real world, and the clipping determines whether the parts that the objects, when they pass in the portal, whether we should clip them or not. And we can see actually in our case, we prefer that the nodes should just come out of the portal and fly to us. So we fully utilize these new features to create a traversable portal for the users. Through the portal, users can not only observe the newly generated skybox that I just mentioned, we just built, and also see the game nodes passing through the portal and appearing right in front of them. Then they can interact with these nodes. And to achieve this, we can break it into two different steps. The first one is to create another world. Actually, the world is identical to the world we just created. What we need to do is add another single line of code, which is set a world component to the world we just loaded in. So world component is specifically designed for the world that behind the portal. So when it cooperates with the portal, then the portal knows that it will show this specific world behind it. And the second step is to create the portal itself. We need to set the portal entity to use the portal component. Again, a component. So we have a a lot of components here. And this specific portal component accepts different parameters, starting with the world it connects to. So we define the world connected to the portal, and then we specify those two important parameters I just mentioned, the crossing and the clipping parameter. We say, okay, we should allow the nodes coming to us, so the clipping is, we should disable clipping and enable the crossing feature. But if we are just defining like that, the portal will just like appear in front of us suddenly. The whole process is not that smooth. What we do is that we can add some new features like that. If we add these kind of feature animations, the portal will appear in front of us very gradually, and people will see it more natural and fluent. So how we implement this, we are using two different kind of cubes in front of the portal and apply occlusion material to that cube. And we can put some animation to those two cubes, and it will gradually open the door for us. Ultimately, we'll see the portal slowly unfolding in front of us. And when it comes to the world, the nodes coming from another world and fly to us. So at this point, we have already completed the design of one single song. We set up the environment, we set up the nodes, we set up the portal. But if we want to make a real game, we still have a lot of more songs, and we want to make it even more interesting. So we can generate a different kind of immersive scenes based on different preferences. As I mentioned, we are using tools to generate these scenes in seconds with our prompts, so it will be a very easy implementation. So for example, we can introduce a Van Gogh-style sky or a castle-themed skybox, just like a Disneyland, and don't worry about the copyright issue. And incorporating with those different kind of scenes, we can further enhance the richness of the game, giving each song a dedicated visual experience and providing players with a more and more enjoyment. And on the main page, we can further enhance our UI system. We design a unique cover for each song. These covers are also generated by different AI tools, but they are for a specific genre or specific song. So they are also the same with the environment we just loaded. We can also have some pleasing and intuitive layout. We can scroll the songs from the right to the left. And finally, we add the finishing touch, which is a neon style title to this UI, which is a GG beat. So the whole part will be also mixed reality, and when user open your app, they can see this beautiful UI in front of them. So now, at last, let's take a look at the final result. So when users, they can select a song and select a scene, and the portal will gradually opens. Then we have our boxing gloves, and we can use our fist to hit the notes, and users can get more scores. Of course, we did not introduce the score system or even the friend system here, but I believe everyone knows that these two systems are in the capability of Apple's ecosystem. So if we adding more songs, adding the more like scoring and friending system, then it will be a fully utilized application which can publish and let many more users to enjoy the game. So in summary, using Apple's native tech stack, we can easily develop a music game. Very easy, less than 500 lines of code. And I know that these several hundred lines is just a prototype, but it proves the potential of developing such games, even such an immersive game. So if you have any game ideas, don't hesitate just to implement it. If you want to talk, you can also reach out to me, and maybe we can do some exciting games in the future. Okay? That's all I want to share today, and thanks to everyone here. Thank you.